سلام. Hello everyone, how are you? Can you hear me? Okay. Welcome to this class. I'm sorry for previous work. The previous week we couldn't hold any meeting, so I sent you two video materials for to design pattern. As I asked you in this lecture, I want to have a practice uh, to know how to apply them in our case study. Let me share the screen for you. Excuse me, firstly I make a record, then I share it. Okay. As you know, in previous lecture we talked about creational design patterns, and we have done a practice about applying the uh, singleton design pattern uh, on our case study, on our ATM case study. In this session, I want to talk about the factory method and the builder design pattern. Let me to start from my textbook. If you have seen this textbook, each design pattern is discussed in the and in each design pattern you can see a sample about how to apply the design pattern in practice, and then it's concluded with the advantages of using design pattern. Uh, in the first part of this session, we will talk about the factory method. If you see for you, the factory method would be applied when a class, a superclass, and in practice, when we want to develop the application, we couldn't predicate which subclasses will be instantiated in practice in runtime. So we should make a suitable implement to do the instantiation at runtime properly. As you see, the first part of factory method talks about the intention of the factory method. It defines an interface for creating an object, but let subclasses decide which class to instantiate it. How you can apply this method to study. In this slide, you can see our design for This is our class for the ATM case study. Could you find any match in these classes for using factory method? Please write your answer. Can you tell me? I think you have not seen my video materials. The account not. No, no. Please note in our definition, you can find that we can apply the factory method when we have subclass and superclass relationship in our class diagram. No database class has not any superclass or subclass. Please diagram with more detail. You can see the only inheritance relationship is about the transaction class. The transaction class has three subclasses: withdrawal, deposit, and balance inquiry. As I told, in practice, we could not anticipate at runtime our clients, our users, which type of transaction they want to do. So we just know some transaction could be or should be instantiated. In this case, for example, when you start to working with the ATM system, you may start with a balance inquiry uh, question or this deposit type. Okay, so you cannot anticipate uh, anything about which user start with which transaction type, but you know just some types of transaction should be instantiated at runtime. In this case, we should prepare a mechanism to select any subtype object or subtype instantiation at runtime. So the only match in this class diagram for applying factory method is the transaction class. So we should implement a transaction factory or a factory method for class transaction so that in runtime we could select the type of sub classes or the type of the transaction and pass to the factory method to instantiate a proper object. Okay, so let's go back to the textbook and talk about how factory method help us when you want to instantiate any subclass. Let's go. We read again this definition. The intention of the factory method is define an interface. What is an interface? Do you know what is interface? The interface is a simple method. Okay, it's a simple method. So we want to define a special method named factory for class transaction, and at runtime we can pass the type of transaction to be instantiated to this method as a parameter, and the method should instantiate and make a new instance of the proper class and return it to the client. Okay, so it define an interface for creating an object, but let subclasses decide which class to instantiate. Okay, uh, you can read this motivation uh, about the philosophy of using factory method. I talked a bit about this motivation. As I told you, at runtime, we could not subclasses to be instantiated. Okay, this is common for some frameworks. Frameworks use abstract classes to define and maintain the framework is often responsible for creating this object as well. Okay, let's go to the next part and to define how this factory method help us in creating proper uh, instance objects. In this design pattern, we have two main components. One is named as creator and one is product. The product is the instance is an instance of the proper subclass. Okay, and the creator should have should has a factory method. Okay, by running this factory method, by calling this factory method, it should return a new instance of uh, that object, that class which we want. Okay, so we have a creator class and product class. Could you tell me, can you tell me which of these classes in our ATM case study match could be matched as a creator, and which ones could be product? Please write your responses. I repeat again my question. Please note, uh, as you see in video materials, we have two components in this design pattern. One is creator class and the other is the product class. Uh, which of these classes among transaction class, withdrawal class, deposit, and balance inquiry can be matched with creator, and which ones could be our products? Let me read your comments. It's like some class have one root in program. No, no, this is not correct. The creator in this case can be the transaction class. In general, class that should instantiate any instances of our submitter class is the transaction class, and our products could be an instance or instances of these subtypes: withdrawal, deposit, and balance inquiry. I think you need to see again the video lecture. I sent I sent it I sent them uh, with a delay. I sent them today. You may have not enough time to check them with enough details. Okay, so please see again the video materials and check comments of the using a factory method. In practice, when we want to use this design pattern, we should define some abstract classes such as product class and creator class, and we have let me to show the example, the sample that is used in the video. Terms one of several possible classes that share a common superclass, several possible subclasses that share a common superclass. We can use the factory method. For example, let me to present. In case this superclass have several subclasses, and we want a method to return an instance of its subclasses. Okay, so in this case, we can use factory method to make proper instances. Okay, so let's go back to the video material. The factory method creates a new enemy, for example, in a game. For example, in a game, you can make an enemy, and as you have experience in gaming, several enemies could be defined in any uh, gaming, in any game. So a new game enemy, when we want to create a new enemy, it's not predicted before runtime. In design time or in development phase or in implementation phase, we cannot anticipate, we cannot predict which type of enemy should be instantiated. This could be determined in runtime. In runtime, a user select an enemy type, and an instance of that type should be instantiation. So this is a good example for using a factory method, because several enemy entities could share can share a common super enemy, for example, and a random number generator picks a number assigned to a specific enemy. For example, in practice, when a user selects one enemy shape, one enemy type, before in design time, it has dedicated a number, and a random number could be used to select which enemy could be instantiated at runtime. The factory returns the enemy associated with that number. Okay, so the class is chosen at runtime. Let's go ahead in this lecture and talk more about using factory method. When to use a factory method, when you don't know ahead of time what class object you need. For example, what type of enemy you need, or what type of enemy your user want to make an instance of it. Okay, or for example, which transaction at runtime should be instantiated. We cannot, we don't know ahead. Okay, we cannot anticipate the type of our subclasses should be, which type of our subclasses should be instantiated. So when you do not know ahead of time what class object you need, you can use factory pattern. When all of the potential classes are in the same subclass hierarchy, this is the same as our talking in previous slide. To centralize class selection code, we can use a factory method. As I told before, a factory is an interface, is a method of our creator entity. In the example of ATM, for example, the transaction could be a centralized class that could have a factory method. When you don't want the user to know every subclasses, for example, there are several subclasses that all of them didn't known for the user, for the developer at development time. Okay, we can use the factory pattern to encapsulate object creation. We can use the factory method. As you saw in this video, for example, we have a client class, we have a factory class. For example, in this case, in the case of game, an enemy ship factory class could be declared, and we can use a super class which has several, which has in this case two subclasses. The enemy ship is our super class, and the UFO enemy ship and rocket enemy ship is are the two subclasses of the enemy ship. In implementation type, we cannot uh, which type of this enemy should be instantiated. This could be selected at runtime by our user, by our gamer. Okay, our user tell the system which type of these enemy ships should be instantiated. For example, one user uh, select the UFO enemy ship, other user or another user uh, has likely to uh, create a rocket enemy ship. Okay, so this is a good example for talking about the enemy ship, the factory. So the factory design pattern allows you to create objects without specifying the exact class of object that we create. Okay, if you go ahead with this video material, you will know how to apply the factory design pattern to this case study. For example, we have an abstract class enemy ship, as I told in its UML diagram, and we it's a UFO enemy ship and a rocket enemy ship, and we should a creator class or a factory class named enemy ship factory, and a client that can call the factory of enemy ship. Okay, uh, let's me to come back to our case study. In our implement, which I sent you before, define the ATM class as a client for the transaction class. Transaction class could be a creator class, and our products could be one of these three types: withdrawal, deposit, and balance inquiry. Please implement this exercise for next session. Okay, exercise. You have you do an exercise about this factory method. Okay, this is our lecture that I've used in previous meeting. One of the design patterns that talked about it is the factory method, and uh, all comments that you are needed is presented in GOF textbook, so you can find the details about how to use this uh, design pattern in practice. The next one, the next design pattern that I want to talk about is the design pattern. Can me when we want to use builder, or when we can use builder pattern in practice. And for example, in our ATM case study, how you can use or how you can apply the builder pattern. Excuse me, you need to have more practice to do more practice. about using these design patterns. You have enough time until next session to apply these design patterns in our ATM case study. Probably you have seen in a video lecture that the builder pattern behind the class of the system uh, have some parts of have composition relationships with other classes. For example, in the ATM case study, the ATM class has part of relationship with deposit slot and keypad and cash dispenser and screen. As you know, and as I told you before, the ATM class is an aggregation of deposit slot component or class, keypad class, cash dispenser, and the screen class. In the builder design pattern, we want a mechanism to instantiate new object of ATM. When we want to instantiate an object of the ATM class, you should initialize any parts of this class. For example, you should initialize the deposit slot. You should define an instance of keypad. You should have an instance of screen. When you do all these instantiations, your code will be so messy. Okay, and confusing. This design pattern help you to refactor your code so that you could instantiate this class more easier than before. Okay, let's go to the builder design pattern in our PowerPoint slide. The intent of this design pattern is to separate the constructing of complex object. In this case, we define complex object as objects that have several parts. For example, the ATM have several parts. The ATM has a screen, has deposit slot, and so on. Okay, so the ATM class is a complex class, and when you want to instantiate a complex class, you should define any parts of the complex class. Okay, so this design pattern try to separate the construction of a complex object from its representation so that the same construction process can create different representations. For example, in this case, as you see in this slide, we have a text converter and a reader class, which can read several files. Okay, excuse. Hello, hello. Sorry, hello. سلام باشم. خیلی بعداً تماس بگیرم. لکلاس باش. Sorry, in this example, uh, we have a reader class which can read several file types and a text converter which can convert to several to other types. For example, an ASCII converter, a text converter, and text widget converters are subclasses of this class. Okay. In this case, we have several parts for our text converter. When you want to instantiate an object of this type, you should instantiate all parts of the main class. So it could be a complex object, and the instantiated of this object could be complex. So when the algorithm for creating a complex object should be independent of the parts that make up the object and how they are assembled. You can use the builder design pattern. Let's go back to our case study. For example, in this case study, when you want to instantiate an ATM class, you should define an instances of these parts, of its parts. Okay, we want to do this separately in another class. Okay, so I want you use the two video materials and apply these design patterns to the ATM class for next session, so that we can make our change in our implementation to applying these uh, design patterns. Okay, please do this exercise for next session. In next session, I want to implement or apply these design patterns in the ATM class. Let me see your messages. Excuse me. Complex objects to be simplified. No, we cannot simplify the complex object, but the process that we instantiate them could be done more easier. When we use this design pattern, we could instantiate its parts in more elegant way and in more easier way. Okay, the complexity of the object could not be reduced. This is not true at all, but we can do the instantiation process in a more easier way. Okay, so please do this exercise for next session. In next session, we will implement these types of design patterns in our case study. If you have any question, please ask your questions. You should see those lectures that I sent you more than one time. Yes, you need to see again. I told you how you can apply those design pattern in this ATM case study. The first one should be applied in the transaction class, and the second one should be applied to the ATM class. The best match for builder design pattern is the ATM class, and the best match for the factory method is the transaction. For example, in our implementation, we have a main menu that take the user offers to make any transactions. In that part, you should make your change, okay? And you should use the factory method for instantiate your actual transactions. Mr. Muhammad, I think you have a question. Please type again. Okay. So I think it's enough for tonight because you have two lectures to see again, and you should do an exercise so that we can continue in our implementation ID. Okay. If you have no question, let me to finish this lecture. I have sent you the implementation of the ATM case study before in your WhatsApp group. Okay. You should change that implementation. Okay. So let me to finish this meeting. Uh, I have a question about the implementation of the algorithm for ATM when a balance inquiry is not executed or I don't notice, Mr. Mohammed. Question mark appear. I don't got this part of your question. What's the question mark in your implementation? We have no any question mark. Let me next session I will talk on the implementation code. I cannot remember the question mark in the balance class. I think we have no question mark in our implementation. Maybe you have used another version of the ATM case study. Please use the version that I've sent you. Let me to talk in implementation environment next session. I don't remember. So please send me your implementation. I'll check it. Thank you. My program implemented in my computer. Can I change code? You can change it if you have implemented exactly this class diagram. If you have implemented another version of ATM case study, maybe you could not apply these design patterns on your implementation. If you have used this design and this class diagram, you can change it. Okay, thank you for your attention. Bye for now.